Hello everyone, welcome to Microcontroller and Embedded System Lab session. Before I begin with the lab session, let me revise you about the ARM7 TDMI and the LPC2148 features. Firstly, the ARM7 TDMI is a general purpose 32-bit microprocessor. So ARM7 TDMI is nothing but an ARM7 with a 16-bit thumb instruction set plus a JTAG debugger plus fast multiplier with an enhanced IC. So that will be implementing ARM version 4 instruction set. It offers high performance and a very low power consumption. So here the architecture is based on the RISC principles. So what is RISC? It is nothing but the reduced instruction set computing. So when you compare with your complex instruction set computing, this particular instruction set and the decoding mechanism are much simpler than your complex instruction set. Because of this, it offers a high instruction throughput and an impressive real-time interruptive response time from a small and cost-effective processor core. As everyone knows that we use the pipeline technique, when one instruction is being executed, the second instruction will be decoded and finally the third instruction will be fetched from the memory. Also, it uses a thumb architectural strategy that is suited for high volume applications with the memory restrictions or in application where the code density is a problem. Various applications could be the industrial control, medical systems, access of control and the communication gateway and also embedded soft modems and general purpose applications. The ARM7 TDMI has two instruction sets, the standard 32-bit instruction set and a 16-bit thumb instruction set. Before I go into the features of LPC2148, let me tell you what is LQFP. So this is nothing but an LQFP 64-pin package where it is nothing but low profile quad flat package. So it provides the same benefit of the metric QFP packages. So what is QFP? Quad flat package is a surface that is mounted integrated circuit package with a gull wing. Okay, gull wing is nothing but an extension from each of the four sides. Coming to ARM7 LPC special variants include features. Low profile QFP. The first feature is that the 16 or 32-bit ARM7 TDMIS microcontroller, it consists of a tiny LQFP 64-bit package and also 8 to 40 kilobyte of an on-chip static RAM and a 32 to 512 kilobyte of a chip flask program memory. It has a 128-bit wide interface or accelerator that enables high-speed 60 MHz operation. It has an in-system or in-application programming feature via on-chip bootloader software. It also has a single flash sector or a full chip erase in 400 milliseconds and programming of 256 bytes in 1 milliseconds. And the interfaces that offer real-time debugging with an on-chip real monitor software and high-speed tracing of instruction executions. It has one or two 10-bit analog to digital converters and provides a total of 6/14 analog inputs with the conversion times as low as 2.44 microseconds per channel. It has two 32-bit timers, also has external event counters including 4 capture and 4 compare channels each, and also a pulse width modulation unit consisting of 6 outputs and watchdog. It also has a low power real time clock with independent power and dedicated 32 kHz clock input. Finally, the multiple serial interfaces that include two UARTs, that is nothing but universal asynchronous receivers or transmitters, and also integrated circuits, that is nothing but multiple chips that is connected to the same bus, and each one of them act as a master by initiating the data transfers. The following image shows the LPC2148 pin configurations. The following depicts the functional block diagram of LPC2148. Summary of a system control block functions. The system control block functions will include several system features and control registers for a number of functions that are not related to specific peripheral devices. These include such as crystal oscillator, external interrupt inputs, miscellaneous system controls and status, memory mapping control, the phase lock loops, power controls, reset, advanced peripheral bus dividers and wake up timers. Now let us begin the demo sessions of Part B lab programs one by one. Here we are opening the kit of LPC2148 ARM7 TDMI microcontroller and the equipments used for the kit. This is the ARM7 LPC2148 evaluation board. Now let us study the parts of the evaluation board. Firstly is the LPC2148 daughter board. So this is LPC214 daughter board. Now this is the power supply connector. This is the serial port. Next is the JTAG connector, and also next you can notice that JP7 and a red color ISP switch. Next is a reset switch SW9. Next is the yellow colored and black ones are the LED switches in the switch circuit. Next is LCD contrast and the LCD display. Next is the 7-segment display. Next the DC motor, the stepper motor below it. Next below the jumper we have the external interrupts. Side of it is the 4x4 matrix keypad. Next is the ADC, that is analog to digital converter. Now we have the DAC output. Next the pulse width modulation output. Next we have is the buzzer. So before a buzzer it is the relay, and below the 7-segment display we have the board, that is serial peripheral interface and inter-integrated circuit. Now let us see the required accessories to run the kit. First thing is, for developing the program and generating the hex file we require a computer. Next a serial cable for downloading the hex file, and a standard power supply and an adapter for 5 volt of 1 ampere. Now let us see how to connect the serial cable. Connect one end of the serial cable to the PC. So this is how we connect to the PC. Next we need to connect the another end to the evaluation board serial port. So this is how we connect to the evaluation board. Then connecting to the power supply using either the adapter or by the power supply. This is our power supply connecting to the power supply connector. So this is the power supply. So now we are connecting to the power supply connector. Now if you want to use the adapter of 5 volts or 1 ampere, then connect it through this particular connector. So this is how we connect the power supply. Now coming to C programming. First step is to open the Keel uversion 4 and then project, new uversion project. Next create a new folder and name it, and click on the folder and give the file name and give save. Now it will pop up this window for selecting the device. In search, give as LPC2148 and then give OK. As now we are using C programming, give as yes. Next, click on target 1 and then source group 1 and then start up. Next, scroll down and you have a configuration wizard. Check on VPB division setup and uncheck on PLL setup, that is phase locked loop, and save. Next, click on the file and type the program. This is the program of LED blinking. Once the program is being typed, save and give the file name as led1.c and save. Next, right click on the source group 1 and add existing files to the group and select the save program and give add. Then build target and check for any errors. If any errors, clear it. If no, can proceed by clicking on project options for target 1 and here go to output, click on the checkbox of create hex files, then click on the linker, click on the checkbox of use memory layout from the target dialog box and give OK and then save. Then again build target to create the hex files. Now next is to download the hex files. For that, first step is to click on the flash magic. In the COM port, here in the COM port, select COM5, that is COM5, and select next, and select device LPC2148, OK. Then go to my computer and manage device manager and check if the ports communication port is COM1 and USB serial CH340 is COM5. So this is how we have already set there has COM5. Next, we have to browse for the hex files that is created. So click on browse and check for the blink.hex file. Next, once the hex file is selected, so we are still on the process of selecting the hex files. So once we select it, next go to options, advanced options, then check whether the hardware configuration both should be checked and then OK. Now check that if the erase all flash is also checked. If it is checked, then we can click on start. Once you click on start, it starts verifying. After verifying, it shows that it is finished. Now we have to check the output, that is the results. So now finally we are going to check the results. That is the first program, that is LED blinking. Now in the switch circuit you can see the output, that is the LED is blinking. All the LEDs are blinking. Now coming to the stepper motor. First thing is you have to connect to the stepper motor circuit with the cable there of the stepper motor, and then once the program is being typed, once it is typed, you can check the output in the same procedure. So you can see that the stepper motor rotating clockwise and anti-clockwise. Now coming to DC motor, same thing, we have to type the program. Once it is typed, the same procedure is followed. Connect to the DC motor circuit there. Once it is connected, you can check the output here. So this is how the DC motor runs. You can observe the rotating of the DC motor. Now coming to 7th segment display. As the program is written, now you can check the output, that is from 1 to 14, that is up till A9, then A, B, C, D, E and F. Next is 4 into 4 key matrix. Check the output here. Once the key is pressed, you can notice in the display the output, that is from 1 2 3 as per the inputs we are giving. You can notice the key that is being displayed here, that is in the keypad testing display. Next we'll see the ADC, that is analog digital converter. So here you can see in the output, as we require it is 3FF the output. The value keeps converting until you get the output has 3FF. So please check here, it is 3FF and then it finally stops. Next we have the DAC, that is digital to analog converter. Now connect the CRO probe red wire to A out and black wire to ground. So once it is connected, you can check the CRO where you have a square output, triangular output and the sinusoidal output. So these are the outputs that is shown in your CRO. The next program or the next output we are going to see is the external interrupt. So in external interrupt, initially it will be in off state. So when you press the interrupt switch, once it enters the F loop and next it enters the else loop, that is nothing but else will be consisting of the IO clear and the F will be consisting of IO set. So IO set is nothing but you're setting the register and IO clear is you're clearing the register. So here you can see once you press the interrupt switch, you can see the LED off and on. So this is the output of all the programs. Here we come to the end of this session. Thank you everyone.